Hello, everyone. Welcome to Chippy, the Chicago Python user group. I'm Joe Jasinski. I'm one of the organizers, and I'll be the MC for today. Today is our Dunder main meeting for June 2020, and we usually hold the main meetings the second Thursday of every month. So welcome, and thank you for joining us. So first, before we get started, I'd like to mention we have a code of conduct. Oops. Which is basically we set the code of conduct so as how we want people to behave in person and on our online space. So please treat people with respect. A review of our code of conduct is available on our chippy.org website. But so what is Chippy? Chippy is as I mentioned, the Chicago Python-based user group. We are a Python-focused community that started in 2003, and we started meeting in the back of a bar, and now we've grown to be one of the largest Python communities in the world. We have a number of events each month, and we have thousands of people on our various online portals. So Chippy is is made possible by our Chippy board, which these are the people who lose sleep at night to make sure that our meetings take place. And but in addition to the board, we have a ton of organizers that organize different events and various other volunteers who make Chippy possible. So a great thank you to all the people that help work with Chippy. Chippy has a number of initiatives. One, we have Python Project Night, which is a space and time allocated for people to come together and work on their personal or group Python projects. In the past, this has been in person, and we hope to get back to that point. But it's a good opportunity for people to learn from each other and ask questions and seek for guidance. We also have some activities that take place during Project Night. So a really cool project. Also, we have a mentorship program, which is changing to a new program called the Buddy Mentorship Program. And this is an initiative that's still being worked out, but you can find out more by going to chippymentor.org, and we'll be posting updates about that as it evolves. So in addition to having our main meeting, we have a number of special interest groups which let us dive deeper into specific Python topics, including finance, data, web dev, DevOps, and algorithms. So we have all sorts of activities going on, and we're really excited by the different types of talks that happen each month. And speaking of that, we have a few meetings upcoming. One is on June 17th for the data SIG. On June 2nd, we have the algorithm SIG meeting. July 19th is our next, July 2nd, I mean. July 19th is our next main meeting. So you can find out more information on our meetup page if you want to find out the meeting link. So we have a very active Slack community. You can join Slack and engage with people of all different, all different types of people who use Python and talk about all different types of Python related things. So here's our link on how to join. Please come and participate. We also have a Twitter account at ChicagoPython, which we post updates and news. So feel free to follow that. And if you don't remember any of the links I just mentioned, you can find all of that information on chippy.org, which is a basic landing page for all of our events and links. So check that out, and yeah. So this takes us to our June main meeting, which we have some great talks planned for today. So I'm really looking forward to that, and you'll hear from our speakers very soon. We have on the right-hand side of the screen a chat box, which you can engage and participate. If you have questions for the speakers, feel free to ask them in this chat box. And just note that there's a few second delay between when we talk and when there's a broadcast. So if you have questions, to avoid dead air, if you wouldn't mind just asking them a little bit before the Q&A starts, so we have some questions in the bank. With that, I'd like to open up a question or a discussion topic for our chat. How have you been using Python lately? Post what you've been working on, what kind of interesting projects that are Python related. We'd love to hear what's going on in the Python world. With that, we have a quick announcement. I'd like to introduce Ali Sivji. Ali's also been helping with the stream, so thank you very much for that. Here he is. Hey, Ali.
Hey, everybody. Hey, Joe. Thanks for having me on. I'm here to just let everybody know about a conference that's coming up. Next week, it's going to be the second annual Python Web Conference. This is a conference that's focused more on the web development / DevOps part of Python. This has been a virtual conference since last year, so they've been virtual since before it was actually cool. Tickets are available. If you use the code Chippy15, you could save 15%. And Joe, can you go to the next slide?
Yep.
We're going to be giving away a ticket. It's going to be at bit.ly/Chippy/June/11-giveaway. Join us at the end. We're going to pick somebody using the Python random module. So we're going to have some live coding at the end. There's going to be one ticket to give away, so good luck. May the odds be ever in your favor.
Thank you very much, Ali. So with that, I'm going to bring on our first speaker. This is Adam. Let's see. Let me bring him onto the stream. Hey, Adam. Welcome. Good to see you.
Thanks, Joe. You too.
So,
hi, everybody.
Adam, yeah. So yeah, Adam. Yeah, we've known each other for a while. Adam's also one of the Chippy board members. But for the sake of everyone else who's watching right now, tell us a little bit about yourself, how you use Python, etc.
Sure. So I've been using Python for off and on for almost 15 years now, and seriously for about 12. I was a freelance web developer using primarily Python for a couple of years, and now I mostly use it as a hobby, although I do still do some Python at work at PayPal. So feel free to ask me about that over email or something later. Yeah, and today I'm going to be talking about using Python to program hardware.
Cool. Besides Python, what are your other favorite languages?
I don't know about favorites. I write a lot of Ruby at work when I'm writing code. I also do some Java, and I enjoy me some Bash scripting. Great.
Well, thanks again for joining us. And with that, let's get started. I'm going to share your screen.
Great. So I don't have any slides today. I'm going to be between showing you things using my video feed and showing you code in an editor. So the piece of hardware that I'm talking about today is called the CircuitPython Express. And you may remember this if you were at PyCon last year, as it was the subject of the closing keynote, and everybody who attended got one in their goodie bag. So if you're, and the code I'm gonna talk about today is actually available in the example repo from PyCon last year, because that's when I wrote it. So if you Google PyCon CPX, you'll be able to find this code. It's in the attendee examples directory. And yeah, it's inspired by the closing keynote by Nina Zakharenko, who has previously come to Chippy events with me. And part of the talk will assume some basic understanding of Python generators and Python decorators, but most of the content will be interesting for anybody, even if you aren't familiar with those Python features. So let's talk a little bit about the CPX, or CircuitPython Express. It's a little circuit board, a little bigger than the cross section of a golf ball. And it has a lot going on. Around the edge, you can see basically electronic touch points that are capacitive and let you send signals to it by touching them. They can also do electronic input and output. There's a couple buttons on it here and here. There's a switch right down here, and some LEDs up at the top. You see the green power LED, and there's a red one that you'll see later near that, as well as a USB port that I have it plugged into the computer on, or you can plug in a USB battery, and another port on the other side that I have no idea what it does. I think you can also plug a battery into that end. So yeah, so that's the hardware we're talking about here. And it's got a little tiny processor on it called an ATS AMD 21 that runs at, I think, 45 megahertz. It says all this on the back, which is why I'm looking at it funny. Yeah, and it can take 3 to 6 volt DC current. And you can do all kinds of fun things with it. So before I show you some features on it, I want to talk about how I'm programming it with Python. So generally, you can't run Python on microcontrollers this small historically. However, a few years ago, there's a project called MicroPython that was specifically designed to allow Python to run on small boards like this. And then there's a variant of that called CircuitPython, which is what runs on the Circuit Playground Express. So it's really easy to install. You basically plug it into your computer over USB, you drop a file onto it, and suddenly it's just running Python. It disconnects from your computer, reconnects, and all you have to do to then run code on it, as you can maybe guess by the code that's up on the screen, is you basically save a file on the hard drive that it adds to your computer called code.py, and it just runs automatically when you save the file. So next, let's talk about this editor that I'm using over here. It's called the Mu editor, and it has sort of two features that make it really nice for Circuit Playground development. One is that it actually forces the file to be written out to disk whenever you hit save. It makes sure that the file is not buffered in memory or anything like that, which is a problem with editing code directly on the Circuit Playground with most editors. So that's really convenient. The second thing is that it has down at the bottom here, a built-in console on the device itself. So if I want, I can actually like type code into the console, into the device itself right down here. And if there are errors in my code, those will show up down here as output. So it makes it really easy to sort of interactively write code on the device when you're experimenting. If you were going to write a 1,000-line program, would you want to do the whole thing in this editor? Maybe not. But for small things or for debugging, it's really convenient. Cool. So without talking too much more, let's start to talk about what this board can do. So the first feature is if you tap it, it blinks a red LED. So the code that you see on screen is exactly what's running on the device. It's literally showing you the file that's got this code in it on the device. So let's just walk through it real quick. We just import the sleep function. Everybody is probably familiar with that. And then we import the CPX object from the Adafruit Circuit Playground.express library. And that's what we're going to use to actually control the hardware on the board. So the first thing we do is set up some configuration for how the tapping works on the board. This is all relatively well documented online. And this is just necessary to make it sort of reliable. If you don't set it to this setting, you basically just every time you move it, you get a tap detected. And then I've got this function flash on double tap. And so it just, while true, which means running forever. If the device has been tapped since the last time we checked, then 3 times I want to run through this loop. Turn the red LED on, sleep for 0.2 of a second, turn it off, sleep for 0.1 of a second, and repeat that 3 times, and then sleep for 0.3 of a second afterwards. And these amounts of time, they aren't magical. I just looked at it and played around with it, and these times just seem to be what makes it work the best, basically. So that's pretty cool. It's got an accelerometer on it, so tapping it is something that you can cause things to happen based on. And remember, while I'm just blinking a red LED, you could send an electronic signal through one of these inputs or one of these outputs around the edge. You could do all kinds of things. So next, I'm going to just show you how I can update the code on it. So I'm just going to take this code here, which is a modified version of what we just saw. I'm just going to copy it. And I'm just going to paste it into this code.py file and save it. And right away, the device is updated. So if I tap it now, no red light. But if I flip that tiny little switch that you probably really can't see on video, Well, it should. Sorry, this was working a minute ago. The problems with working with hardware live. I'm going to hit the reset button, see if that fixes it. Okay, so I'm not gonna demonstrate this, unfortunately, but I'll still walk you through the code, which was working 5 minutes ago. So basically, what I want to do now is control whether or not it flashes the light based on whether or not a switch is flipped. So this adds a little bit to it. I need to track the value of the switch, whether it's on or off, and check whether or not the switch has changed, if I flipped it from on to off or off to on. And then I basically, if the switch is on and it gets tapped, do all the same things that you do before, flash the LEDs on and off. So let's try reloading this file. Cool. All right. So you can see how as you start to use the different pieces of hardware together, like use the switch at the same time as the accelerometer, the code starts to get a little branchy. It starts to have these tracking variables. It starts to just get a little more complex. So what if we wanted to control a different part of the board? Okay, unfortunately, it's not running any of my code when I update it right now. So I'm having some technical difficulties. Let's try resetting it one more time. I'm going to just close the editor and reopen it and reshare my screen to see if that fixes this. Okay, it looks like this code did not get saved properly. There we go. So cool. So now I'm going to show you the next feature, which is now when I press this button, okay, well, I press, sorry for the technical difficulties here. Not sure what's going on, but when you press a button, it starts making it showing these LEDs, and it should turn back off when I press the button again, but for some reason that, okay, there it goes. It turned off and back on again. Back off again. Cool. So now I've got the second program that I can run on it that controls whether or not those LEDs blink. So let's walk through that program real quick. Again, I import sleep and the CPX, but then I'm also importing the ranrange function from the regular Python standard library. I'm setting the brightness of the pixels to their minimum because otherwise they're blindingly bright. And I'm just creating a constant to save the value of a turned off LED, a black pixel, as they're called in the code of the CircuitPython. So here you can see, again, the same basic parts. I've got this section at the top that checks whether or not the button has been pressed and turns the LEDs off and stops itself, or if it's the button has been pressed, then I go through each of the LEDs And if they're turned off, I set them to a random color. It's RGB, so these RAND 256s each select a random value between 0 and 255. So you're setting in like an RGB value, just like you would online. And then I'm doing some normalization. So in order to make sure if the color is values are set pretty low, it actually won't turn the LED on at all. So I grab whichever one is the most saturated, whichever of the 3 RGB colors is brightest, and I just normalize all the values to 255 so that whatever color is brightest will always be at max brightness. So your LEDs will always light up. And then I set them to that. And then otherwise, if the pixel is already lit up, I turn it back off by setting it to black. So as you can see, this is getting a little longer. And again, you've got all this nesting because I have to check whether the button has been pressed, and there's sort of this tracking variable to check that and all that. So let's talk about one more feature, and then we're going to start putting all of this together. So what if we wanted to make the device play some sounds? Again, I'm just going to copy paste some code in here and try and save it, although I'm not sure that's working. Maybe. We'll see in a second. So now, if I touch these touch points around the edge, I can make it play music. And I have it just playing continuously when you let go, but it's the A minor pentatonic scale, so any 2 notes you play will be in tune with each other, which is always a really nice feature. And then I can turn it off by hitting that button. So again, the structure of the program is basically the same. You've got some sort of setup code here to define the frequencies, and then you need to do some initialization so that they're set up to be used as touch sensors. And then again, some tracking variables to track some state, and then checking whether the button has been pressed or not, stopping the music playing if you're turning the button off, and then going through and actually checking all of the touch points one by one, which is what I'm doing here. And then if the touch if it's got a touch value and it's not the same one that it previously detected as a touch, then you want to start the tone and mark that a button has been touched, and so it's playing music, and stop. And if nothing is being touched, then you just want to stop playing. So yeah, so again, just sort of showing basics of what the hardware can do. But what if I want the device to be able to do all 3 of these things at once? I want it to be able to play sounds, I want it to be able to flash the LEDs, and I want to be able to tap it and get it to flash the red LED. Well, I could do that, right? I could sort of interleave this loop with like this loop and with this loop, and then I'm going to have like sort of these on-off tracking for each one. I'm going to be checking the buttons for each of for both buttons and the switch, if they're on or not. I'm going to be tracking, and also I've got these sleeps in here. So one of the reasons that pressing the button doesn't always work when the LEDs are going are because sometimes it's sleeping when you press the button and it misses the button press. So these sleeps are already kind of a problem. And if I can't press any of the buttons or flip the switch and have it notice whenever it's sleeping, which is most of the time because the rest of this code is really fast, I'm going to really have a responsiveness issue on the device. So I need some way to interleave these 3 different features together and also have it still be responsive when it's sleeping. So the code that I wrote that was included in the examples repo for this from PyCon last year, that's basically what it does. So I'm going to walk through this real quick, and then I'm going to show you on the device, assuming that works. So I just have the same sort of setup stuff here, except that you'll notice instead of importing the sleep function from the time library, I'm importing something called monotonic, although I'm calling it now just because that's what I'm used to that being called. But basically, monotonic means that even if the time on your computer changes, like let's say I change my clock to some time in the past, this monotonic counter will still always be, any value I get from it will always be equal or higher to the previous value I got. So it'll never jump backwards in time. So this makes it really safe to use to track how much time has passed and not accidentally get into a place where you think that you haven't passed a lot of time, but actually you have because the clock just changed in between for some reason. So this sleep function is actually really the most important part of all of this, is just these 4 lines of code right here. And all I'm doing is tracking what time it is now, checking whether I've slept long enough or not, and yielding and repeating the while loop as long as I have not slept long enough. So this yield is the magic part here, and this is where Python generators come in. Basically, yield allows a function to suspend its own execution and give up control while still keeping its state and not needing to be called again. And it can then be resumed from that point and keep running. So what that means is this starts the while loop, and then it yields control back to the rest of the program. And when you resume it, it goes right back to the while loop again, right where it was when it left off. And so it just does this loop here forever until the delay has passed and the while loop exits. So that now allows me to sleep for any amount of time I want, but still potentially have the device be responsive by yielding control back to the rest of the program. So let's look at what one of these functions looks like with that in mind. So ignore this thing at the top for a second. I'm going to explain that in a minute. But I still have my while true in here, and I'm still going through every color. And instead of just calling sleep, I'm calling yield from sleep. And so what this says is when I get to this line, instead of this function being in control, I want the sleep function to take over and communicate directly with whatever called this function. So this allows the sleep function to sort of control whether this function is what's being run, or whether it's letting the whatever called this function decide to run something else. So this yield from basically is sort of like inlining a function in C. It basically means that you could consider that yield that's in the sleep function to be here in this function, so that you don't, it sort of unnests the sleep into here so that its yields are basically as if they were in this function itself. So that lets the sleep control whether this function is running or suspended. And it's exactly the same for the play sounds one, where again, there's actually no sleeps in that one at all. You don't need them. But it does have a yield, which you could think of as basically a sleep 0. So this still will yield control back out to whatever called it, meaning that it doesn't block other things from happening. And finally, the flashing on double tap. Again, you've got a yield in here that lets it be paused, and then yield from sleep so that the sleeps let it be paused as well down here. So what does all this mean? This means that I can have this function down at the bottom. I basically can say I want to call my main function with each of those 3 different programs: play sounds, control pixels, flash on double tap. And it does some initialization, and then it just goes through the middle loop. For each of those 3 iterators, play sounds, color pixels, and flash on double tap, it calls next on them. And what next done is run them until it gets to the next yield statement. So if I was just calling with flash on double tap, it would run until it got to this yield and then stop. And then the next time it was called, it would run until it got to this yield and then stop. And the next time it would run until it got to this yield and then stop. And then it would just keep doing that forever. But because I have 3 of them, what that means is it runs and then it gets to here and then stops. And then it goes to the next one. So then it runs and gets to here and then stops. And then it runs again and gets to here and then stops. So now those yield statements magically let these three functions all be run together without the code having to be all mixed up. It still keeps the code separate. And because the sleep itself, which is the only slow thing, has a yield inside of it, that means that even when it's supposed to be doing nothing, it's still allowing the other programs to still run, so they don't block each other when they're sleeping. So let's show you what that looks like. I'm going to take this code. I'm just going to put it into the device and hope this works. Yes, it does appear to have worked. So now I've got a few different features. I can make the lights go. I can turn it into a little musical instrument. And I can tap it, nothing happens. But if I flip the switch, then I can tap it and have that red light blink. All at once, no pauses. When I hit a button, turns off instantly when I hit that button. Turns the sound off instantly when I hit that one. Flashes. Turn the switch off, doesn't flash. So suddenly we have something that's responsive and doing three things at once while still keeping the three different pieces of code separate, all just using the yield keyword and the generator functionality in Python. So that is sort of the basics of my talk. But what we're talking about here is basically multitasking or multiprocessing or multi-threading or whatever you want to call it. You've got three things independently running at once. But this type of multitasking where you have to explicitly call yield to switch between things is called cooperative multitasking, as opposed to preemptive multitasking, which is what sort of happens on most modern computers when you're talking about regular multitasking. But this is a way to do that without having threads or multiple processes or anything like that available, or the async library in Python 3. None of that is available on the Circuit Playground Express, even though it's available in regular Python. CircuitPython does not have those features. So if you want to do multiple things at once, you kind of have to do it yourself, and that's what this is. Now, there's one more function we didn't talk about, which is this gated function. And this is a little more advanced. It's using the decorator functionality of Python, which lets you sort of modify a function at the time you define it by using this @ syntax. So basically what I've done here is I'm gating the functionality of each of these behind a button press. So I'm saying that in order to start the color pixels function, button A has to be pressed. And when I press the button again to turn it off, I want to run the function called LEDs off. And similarly, for play sounds, I want to start it when I press button B and stop the tones from playing when I turn it off. And similarly for the switch, I want to check if the switch is on or off, and I'm just telling it that this is a switch it's checking specifically. The reason that these are wrapped in lambdas has to do with how they're implemented by CircuitPython. But basically, you can just think of them as a function that lets you check whether or not this switch has been flipped or the buttons have been pressed. So there's a lot here, and I'm not going to walk through all of it, but I'm glad to take questions about it if people are interested. But it lets you sort of control, again, without having to mix in all that controlled and those tracking variables into your function, lets you control when your different functions run on it. So between that gated function, which lets you handle the buttons and switches really nicely, and this sort of yield-based generator framework, it lets you cooperatively run several pieces of code at once. And that's all I've got. I'm happy to take questions.
Thank you very much, Adam. That was a really cool demo and a really cool example of using the multiprocessing or multitasking, multi-threading. Now I know what to do with my with those which I got from PyCon. So which does this work with newer versions of Python with like async and await, or could you use that instead?
Yeah, so this isn't, it looks like Python, it's almost Python, it's actually not Python. CircuitPython is its own thing. I can see there's some discussion of this in chat. it does not quite match the Python spec. So it's roughly Python 3. This yield from syntax is a relatively recent Python function that I'm using, in the sleeps. But a lot of the like async threading, things like that just don't exist in CircuitPython. I know there was some open pull requests and stuff like that to add them, but last I checked, none of it was added to CircuitPython yet.
So, how often do they update can you update the firmware for this periodically for CircuitPython?
I have to be honest, I have not updated it since PyCon last year, so I am not totally familiar with the newest changes.
Okay. Where can we find more information about about this kind of programming, or where did you learn it?
Yeah, I mean, my introduction to it generally was just in Nina's keynote last year, and through spending some of my time during the sprints after the main conference at PyCon last year, working on it and learning about it. The people from Adafruit were there and had a room set up, so that was really cool. Adafruit is the company that makes them. If you're going to buy one, recommend buying it on either Adafruit or DigiKey. That's what Adafruit recommends. And if you just Google CircuitPython, Circuit Playground Express, PyCon CPX is how you can find this code that I'm showing today. There's lots of information out there about it, and it is really very easy to use.
Great. Well, thank you very much. I don't see any more questions at the moment, but if anyone does have questions, feel free to ask in Slack. And we can continue the conversation there.
Thanks a lot, everybody.
Thanks again. Bye. So that was our first talk. Thanks again to Adam for that great introduction to multiprocessing. I'd like to bring on our next speaker, Brianne, and let me get her onto the stream.
Hello.
Hi. So welcome to Chippy. Thanks for coming to speak with us. Why don't you tell us a little bit about yourself?
Sure. My name's Brianne Caplan. I'm the executive director and founder at Code Your Dreams. I'm also the CEO and founder at CoderHeroes, and I am a data scientist today and tomorrow. And then I started a new role at the University of Chicago as the program director for careers in computer science.
Cool. So besides Python, what languages do you enjoy using?
So I'm just a Python girl.
Okay.
But for teaching, I taught Python for a year. That was amazing. I love teaching with App Inventor. It's block-based coding that was created by Google and is licensed by MIT. Great.
All right. Well, without further ado, let's get started. Thank you. Thanks again.
So I will share my screen.
Okay, let's see. All right, I'm gonna add you to your screen to this. There you go.
Awesome. Okay.
All right. Thank you.
So I'm so excited today to talk about two organizations that I'm really passionate about, and that is Code Your Dreams and CoderHeroes. So this is me. My handle for most things are Code with Brie. I'm newly on TikTok since I work with kids, and I've been trying to create mini coding lessons on TikTok. So I'll get into it. So as a woman in computer science, I often felt like coding wasn't for me. And so when I made it into my career as a data scientist, I really wanted to give back. So I started a program on the South Side with a group of girls, and there are a few things that really surprised me. One, which is probably the least surprising, is that none of my students had computer science classes at their schools. Number two was that half of my students didn't have internet access at home. And number three is that half of my students didn't have basic science teachers at their schools. So these things really shocked me. And so I started digging and researching into the inequities that exist within our education system. And what I found was that coding education access needs to improve. I know I'm preaching to the choir. So The stats are 45% of high schools don't have computer science classes, although 90% of parents want their child to learn computer science. And I'm talking to Chippy, so we know these are awesome jobs that require coding skills, pay up to $22,000 more per year on average, and programming jobs overall are growing 12% faster than the market average. So coding education is something that needs to be disruptive, and it's right to be disrupted. So I started doing my research, and there are a lot of tech programs out there, but there are three problems that I really found. One was that technology and all of its advantages are not equitably distributed. Number two is that tech programs are typically located in high socioeconomic areas, such as downtown Chicago and on the north side, leaving many communities disconnected. And the map I have here is computer science deserts in Chicago. Number three is that traditional tech programs ignore community issues and the potential for applicable impact. So when starting Code Your Dreams, our solution is focused on number one, being equity-based, number two, socioeconomic based, and number three, being community-based. So starting with equity, we provide our students with everything that they need to be creators of technology, not just consumers of technology. So within our program, we provide our students with laptops, hotspots for internet, and Android devices as they're developing mobile applications. Number two is that we're socioeconomic based. So we focus on students who need this the most, and those are low income and minority students. And number three is that we're community based. So too often technology is being built at communities. So instead we put the power in the hands of our students to solve problems that they experience every day with code. This comes down to every part of our curriculum. So for example, with the user research and user testing components of my students' app development, they do that user research and user testing in community spaces like neighborhood coffee shops, parks, to really test and include everyone in the community. So what is Code Your Dreams? Code Your Dreams is a 501c3 nonprofit. Our mission is to make coding for everyone. And we aim to empower youth action and youth voice with code. So we were founded in 2018. Up to now, we've served about 250 students, and we're really ready to expand past that. So what our program looks like is we're an after-school program. It runs anywhere between 12 to 16 weeks. Our students have developed over 80 mobile applications to date. These mobile applications, our students have identified over 50 communities that they'd like to impact with code, and over 100 problems my students have identified that they would like to help solve with code. This is just the overview of our curriculum, so the phases of app development that my students go through. So they start with the design thinking phase, thinking about their communities, problems that they experience in their own lives, and then they go through the app development process of each student individually coding, building, designing an app that addresses that community problem. So what's important here is that our students are exposed to all of the different career opportunities in technology, from product and project management, UI, UX design, software development, and sales and marketing. And something in there really sparks an interest in every single student. So things were going great. And then COVID hit, which really threw a wrench in like everyone's lives. Schools closed, our funding needs increased, and we needed to reorganize as a nonprofit and move everything that we were doing virtually. At the same time, and since I have a day job, I had a lot of executives and parents come to me wanting for us to teach their children virtually, and hoping to do so with code. The thing was that they weren't our target demographic, but they were still people who were looking for their children to experience the world of code virtually. So that's how we came up with Coder Heroes. It's a for-profit that we introduced in May, so it's been a month. So we now have this hybrid model where Coder Heroes funds programming for Code Your Dreams. So we have this buy one, give one charitable model where parents who pay for classes and summer camps, that gives to Code Your Dreams to enable us to be a self-sustaining nonprofit. And we also have diversity scholarships up to 100% off tuition for Coder Heroes. So I will plug, if you want to spread the word about that, parents can apply for their kids at CoderHeroes.com/scholarships. So I really wanted to share one of the amazing first grade coders and really let her speak for herself. And I hope that me playing this video and then it'll play back correctly for you.
Category. If you know me, I like to solve problems, but the most thing that I want to solve is I want everyone in the world to be happy. So my invention was how to be kind. So it's an app. Anyone can use it because anyone can be mad. So the most difficult part was brainstorming about how hard I made this app.
So that's a first grade student who's amazing. And I love to share that video. Oops. So finally, I just want to ask, if you want to help, there's so many ways that you can join us. One would be volunteering with us. So we have lots of different opportunities from curriculum development and teaching. You can email me at brianne@codeyourdreams.org. Second is if you work for an amazing tech company and they're looking for philanthropy partners or maybe a way to recycle old tech, definitely connect me with them. We'd love to continue working and partnering with more technology companies, as our mission really is to bridge the skills gap with the high growth technology sector for our low income and minority students. The third is spread the word. It's really helpful for us just to get the word out, especially for like fundraising purposes for us, which goes to number 4. If you are interested in donating, I have the URL below. As an organization, we don't have admin fees or salaries. It's an all volunteer organization. So that's just another way that you could contribute. And that's all I got. So thanks for everyone taking their time to listen to this. And if there are any questions, I'm happy to answer.
Thank you very much. That sounds like a really amazing program. We have a question from Ali. If what kind of apps have your students made so far, besides the one that you showed?
Yeah, so I'll give an example because I see another question is, can I talk about some of the students who've made apps? I love giving this one example, which is a student who came into my program, and as context, the director of the community center told me ahead of time, like, if this student gives you any trouble, just send him to my office, no warning. But because he was a student who had a lot of trouble focusing in class and did not engage well with other programs, but he found a true connection with code. So the experience that he took into my program was that gun violence was something that has directly affected family members. He's seen it with his own eyes. It affects his community. And so he wanted to do something to help. So the user research that he did came to create this the aim of the app, which was that when he walked around his community or his neighborhood, he didn't feel safe, and he knew that others didn't feel safe. So he created an all-encompassing safety app so that if you ever feel unsafe, you can go to it. There are many features for the app. So you can click a button and it'll make a loud siren noise to draw attention to you. You can upload emergency contacts, send text to automate text to your top emergency contacts and then the location where you are. He did a bunch of research on resources, aggregated them in his app. And what's amazing is that not only is this a truly impactful app that can be used like worldwide, wherever you are when you don't feel safe, but it also, this whole experience really like transformed his life. So I love ending that story with him. He walked into my, the community center's director's office, just cavelling about how much he loved this coding class. He was showing his app to the director and he pointed to it and he said, "What is it again? Someone who codes an app, because that's what I want to do when I'm older." And I'll just say, like, that is 100% what success looks like in my eyes, in my team's eyes, is just making sure that everyone, every child knows that coding is something that can be for them, because too often we only see one face as like who is a software developer, and it's not something that seems like attainable for a lot of people.
Is there any other ways that the Chippy community, besides what you mentioned, can get involved? Like, you know, any ways that Chippy can help out?
Yeah, I mean, probably worth a brainstorm sometime. I'd love to get like a good Chippy group together. Maybe we can do some volunteering. We just did a volunteer sprint on Monday that was really fun. Yeah, let's think about it.
Yeah, thank you very much. That's really cool stuff. Everyone give Brianne a round of applause in the chat.
Awesome. Thank you.
Thank you. We're going to have a 5-minute break, but before we do, Ollie wants to make a quick announcement, so I'll bring him back on real quick. Hey, Ollie.
Hey, Joe, can we go back a slide on your computer?
Yep.
Hey, everybody. I'm Ollie Stivgy. I sort of want to just make an announcement. Next week is going to be the Python web conference. They've been, this is the second annual conference. They've been a virtual conference since last year, before it was cool. There's going to be 3 days of talks and tutorials focused around web development and DevOps aspects of Python. There's a lot of great speakers from all over the world. We've got speakers from Germany, Australia. Lorena Mesa from Chicago is going to be giving a talk. I believe she's going to be keynoting on the Thursday. Tickets are on sale. If you use the code Chippy15, they can get 15% off. Joe, can we go to the next slide?
Yep.
We're actually giving away a ticket. Chippy is a community sponsor, so we have a single ticket to give away. So if you go to that bit.ly link, fill out the form. We're going to be doing a live drawing at the end of this meeting. You don't have to stick around till the end. We'll email you if you win. Good luck. Thanks, Joe.
Thank you very much. Yeah. So we'll be back after a 5-minute break and for our last talk with Jess, and we will see you in a few minutes. Welcome back. We are about to get started with our last talk. It's been great so far, and I'm sure it will continue to be great. I'd like to introduce Jess to the stream, and we get started with our last talk. Hi. Oh, I think you're muted. Let's see.
Yeah. How's it going?
Good, good. Welcome to Chippy. Thanks for joining us.
Thanks so much for having me. I am so excited to be here.
Yeah. Tell us a little bit about yourself.
Yeah, so my name is Jess. I live in Brooklyn, New York. I'm a developer advocate at Twitter. Yeah. And I think you have some questions for me, don't you?
Okay, yeah. So besides Python, what languages do you like?
Python's mostly actually the language I work most with. Actually, the code that I'm going to be showing tonight was actually because about 2 years ago, when I first started at Twitter, my manager was like, hey, like, what language do you want to learn that you don't know? And I'm like, I kind of know R, but I don't really know R. And now I can say I know R. So yeah, that's exciting. And then also I make music with Python. So, and I use a Python wrapper for another language called Super Collider. And I've been doing some stuff lately with like raw Super Collider, which has been pretty exciting as well too.
Cool, very, very neat. Cool. Without further ado, I guess we'll get started. And I'll get your. Let's see. Why don't you, if you don't mind sharing your screen, I will get that added to the stream. There we go. Okay, take it away.
All right, thanks so much. Yeah, so I'm here tonight to talk to you about how to run your favorite Python package inside of R. Before I get too deep into this talk, let me know if this inspires you to create anything. You can send me a message at Jessica Garson on Twitter. You can also tweet at me if you want as well. And just in case you want to like take a look at the code that I'm going to be writing, or I know I saw earlier somebody was asking for a code sample. If you want to take a look at it, that can be found at github.com/twitterdev/run your favorite Python package in R. And you might be wondering, like, why would I ever want to run my favorite Python library inside of R? And so the reason why is that both languages are both very widely used for data science. So it makes sense that you might want to use them together. And the way that you do that is through a package called Reticulate. It allows you to run Python code inside of R. And the way that I like to think about this is it's a useful collaboration tool. So when I was first starting to really get going writing code and using Python was in the year 2013 and 2014. And I was working at an organization called the National Education Association. I lived in Washington, D.C. at the time. And I had a coworker that was also in like a similar place to me. She was learning R and I was learning Python. And we never really collaborated. We just kind of were like, oh, you know, we're doing similar tasks. We're doing some data pipeline stuff. We're doing some data cleaning, some data modeling, but we never really like talked about the work that we were doing. And I really wish that we could have like pair programmed together. And, you know, it would be really nice if there was this like accessible tool for interoperability between languages that was available back then. So I see that this is like a really exciting like collaboration tool. And so that's something that's pretty exciting. Also, there are really awesome packages in Python that are not available in R and vice versa. Some of the plotting functionality inside of R is pretty great these days. There's ggplot and there's some other stuff that's available. So it's kind of cool that you can actually these days just use the best of both worlds. And how I got started doing this was I'm very active as a developer advocate at Twitter on the Twitter developer forums. And every so often, people would write us about wanting to use our premium products. We have some premium API endpoints available, and people would want to use them inside of R, and they would write to us, and we'd be like, well, we have a library called CircuitPython that you can use in Python, but we haven't built this in R. And people would be like, oh, well, that's cool, but I want to write R. And so I was at PyData in the fall in New York City, back when we used to be able to like go places and go to conferences and stuff. But you know, I guess this is a meetup, so I'm here, so that's cool. But yeah, so I was at PyData, and somebody was talking about Reticulate, and I was thinking at the time about writing my own version of Search Tweets Python, but calling it Search Tweets R. And then I was like, I heard somebody talk about Reticulate, and I was like, oh wow, I can just like run the Python package inside of R. So I did that, and I wrote a blog post about it that I'll give you the link to. But tonight, I'm going to actually be using my favorite Python package, which is requests, to make an HTTP request and call the recent search endpoint. If you want to type into the chat what your favorite Python package is, I'd love to hear from you what your favorite Python package is. I really love APIs and endpoints and things like that. So yeah, my favorite Python package is requests. And so the recent search endpoint that I'm going to be using allows you to get tweets from the past 7 days. And you might be wondering, what do I need to get started if I want to start doing something similar? So you need to create an app, which will allow you to connect to the Twitter API. And you can apply for access at developer.twitter.com/en/apply for access. And you can also sign up for labs at t.co/labs. This endpoint is available through our Twitter Developer Labs initiative, which is our initiative to rebuild the Twitter API. And we are releasing previews of new endpoints that are available, and you can give us feedback on them. And this is one of those previews. And you can sign up for that at t.co/labs. And you will also need to enroll in the preview for recent search when you do that. And you actually have to go in and connect your app to the preview in order to be able to use it. And then also, you'll need an environment for running R on your machine. Today, I'll be using R Studio. So yeah, this is the live code portion of tonight's demo. So one of the things I love about the Python community is that y'all are so friendly and so awesome. So if you see something, let us know in chat. Since I'm going to be live coding, I will probably have at least one syntax error. It's just what happens. So yeah, if you see something, say something. So now we are inside of R Studio. So the first thing that we're going to want to do is we're going to want to install all the requisite R packages that we're going to be using. So we're going to install Reticulate, which is the package that we'll be using to run our Python code inside of R. We can install dplyr, which lets us work with data in a more robust way. We can also install JSONLite, which will let us work with the JSON payload. We can install a YAML, which we're going to be using for reading in a configuration file. And then we have to call the packages. So this I like to think about as just your import statements up at the top of your Python file. So we're just going to be calling dplyr, JSONLite, and YAML. Cool. So now we have all of that set up. So from here, the first thing that we're going to want to do is we're going to want to set up a path for Python. So what we're going to want to do here is type in our path. And this is actually one of the first places that I made a mistake. I was trying to do Python 3, but you actually had to specify the .version number. And then from here, you want to tell Reticulate to use your Python path. So cool. So now we have that. And now from here, we're going to want to set up our virtual environment that we're going to be using. And so from here, I like to think about the step as like we're just going to be pip installing packages. So we want to do virtual env install, and then we want to do tweet env. And then we also want to install requests. And then we're gonna set that as equal to true. And then we're gonna do what all good developers do, which is cut and paste from their own code. And we're gonna, actually we don't need the slide. So what we're actually gonna do is we're actually just gonna say that we're gonna do virtual env. And then from here, what we're going to want to do is we're just going to say that we want to use the tweet env that we just created. And we want to call it, and we want to say that it's required is true. Awesome. So we have that. And now from here, now this is the point where we can actually start to import in what we're going to need to work with Python. So right now we're going to import in the Python JSON object. You might be wondering, hey, Jess, why are you importing in Python JSON? You have this JSONLite. So there is one part of this code where I was like, I don't know what to do. I really want a Python dictionary. And so the way that I typically make strings into Python dictionaries is to use JSON loads. And I was like, well, I'm already using Reticulate, so I can also use the Python JSON package to do that just as I would in Python. So that was really awesome. So we're going to use that. So we're going to import JSON. And then we're going to set R as equal to importing request. Cool. So now we have that ready to go. And now we can actually set in a line here, a variable called input. And then we can use readLine, which is similar to the input function in Python. And I need to get power, so I'm going to do that really quickly. Yay for live demos. Cool. So now I have power. That's exciting. So now I can ask, this is very similar to like an import statement. So we could do, what handle do you want to get tweets from? And from here, let's do Twitter dev. That's our team's Twitter handle. So now the next thing that we can do here is we can also set up our URL. So from here, what we're going to want to do is we're going to want to use this printf function, and this lets you do string formatting. So for this, what you want to do is you want to do HTTPS : and then we're going to want to do api.twitter.com/labs/2/tweets/search. And then from here, we're going to want that. And then we want to actually set up a query. So we want it to be query equals, and we want it to be from, and this is going to be the handle that we're going to pass in. So we're going to do %s. And then from here, we want to pass that in as input, and that's a variable we just created. And then from here, let's print out the URL just to make sure that we got it right. I think that looks good. I think I spelled query right. I often do that wrong, so cool. And so from here, the next thing that we're going to want to do is we're going to want to load in our credentials. So from here, what we want to do is we want to set up a variable for cred. We could do YAML.loadFile. And then from here, we want to load in secret.yaml. I have inside the GitHub repository, there's actually a sample of what that would look like. So if you're like, oh, what is she loading in? That's it. And so from here, we actually want to pass in the bearer token. So we want to do that. And then one of the interesting things about R is that you have to actually use $signs instead of brackets to slice things. So yeah, from here, cool. And so now we've loaded in our bearer token. And so from here, the next thing that we want to do is we want to create a header. So we can use the printf again. And then you're going to want to set up the authentication as bearer. And we actually want this outside there. And then from here, we're going to want to do bearer. And then we want the %s again. And then from here, since this is a dictionary, we're going to have basically like a string version of this dictionary. Oh, and I forgot to pass in the printfs or the bearer token. So yay for errors. Cool. Awesome. Now we have that. And so from here, the next thing that we want to do is we want to turn this into a dictionary. So this is one of the things that I actually struggled with when I was first writing this code. Is I was like, what am I going to do with this, like, dictionary? Because I really want it to be a dictionary. So I decided to use JSON loads. If anybody has any other ideas about like how they would solve this as well, let me know. It was something I was struggling with. So, but found a solution that worked. So cool. Now we have this We have our header dictionary. So now we actually are set to kind of make our request. So what we could do is we can create a variable called response. And then from here, let's do arm and then request. And then the first thing that we want to do is we want to make a get request. And then we want to pass in the URL. And then we want headers to equal the header dict. Cool, awesome. So now let's print out the response. This is like the most nerve-wracking part of the live demo. This is like where we're going to figure out if this worked or not. Yes, it worked. OK, cool. So we have a JSON response. And we have a tweet about tonight's event. And we have a bunch of tweets and some other things like that. And so now let's actually pass this into a data frame just so it's a little bit easier to work with. So we can do JSON data. And then from here, we could do from JSON, pass in the response text. And then what we're going to want to do is we're actually going to want to flatten this. And what that does is it basically allows, so if you notice here, there's actually two nested dictionaries inside of this JSON object. There's data and there's meta. And so this flattens both of them into one. So if we do flatten equals true, then we get 1. And then actually, let's actually pipe this into a data frame. So let's do, and this is using the dplyr package that we imported as data.frame. And so from here, now we could view this JSON data. Cool. And you can actually see what's coming from the meta and what's coming from data, which is pretty exciting. We have like the tweet IDs, and we have the newest and the oldest. So for the newest one, that's the one about tonight's event. And then we have the oldest one down here, and that's about tweet annotations, which are pretty exciting. Cool. So now let's say we wanted this to be a smaller data frame. From here, we can select, and this again is using dplyr, JSON data. That's the variable that we created for the data frame. And then from here, we can say that we want data.id in there and data.text. And now we can view the smaller df. And so now we have a data frame of just data.id and data.text. So yeah, cool. And so that is the live demo. If you want to see a blog post on a similar topic, that's t.co/Python package R. I also wrote a blog post when I was first getting started with R and the Twitter API that actually walks you through Hello World if you were like a little bit, if that was a little too advanced or you just want to like dig deeper in. It's t.co/getting started R Twitter. And also, if you're building with the Twitter API and there's features that you want to see, if you're like, oh, I really wish that like, you know, there was more OAuth 2.0 support or something like that, you can give us feedback on the features that you'd like to see at twitterdevfeedback@uservoice.com. And if you're building with the Twitter API, I'd love to have a conversation with you and get to know you. And let me know if this inspires you to create anything. My Twitter handle, again, is @JessicaGarson. My DMs are open, so feel free to send me a DM. Also, you can let us know at TwitterDev if you built anything inspired by today's talk, or on the Twitter community forums. As I mentioned, I'm quite active there. Thanks again.
Thank you very much for that talk. That was really awesome. So I have a quick question for you. How do you kind of translate the Python syntax to R when you're doing that? Like it seemed like you needed to use a little, you know, you had to use the $sign instead of the dot. Is there like a specific method to how you think about that?
Yeah, it was actually like, I actually really struggled with that. I was like trying to do dots at first, and then I was like, and then I just like read a bunch of other R code, and I was like, oh, let me try it using it like the way that you would do it in R. There was like one thing that was like super weird at one point, which was at some point there was like this like weird object that was kind of stuck in this like no man's land between like it wasn't R and it wasn't the Python object. It was like in the middle, and I had to like, the only way that I could get it out was to like put it into a pandas data frame, and then I could get it into like, I could just slice that out and get it into my code. So there are some like awkward things that do happen, but yeah.
That's cool. So have you found any limitations in terms of what Python modules you can use with it, or do you think it would work with anything pretty much? Or
everything I've tried to work with has worked pretty well. I haven't had an issue yet, but that doesn't mean that there won't be. If you do hit anything, let me know, because I would like to know before I try to do something, and then I just can't. So most of the stuff I've done has been in like the data science world, though. So
like what kind of specifics? I mean, that was a good demo. How have you used it kind of in your day-to-day?
So as I've been learning R more, sometimes I'm just like, I really wish there was this Python package I wanted to use, just because like I come from Python. So I've just mostly used it to like be like, oh yeah, that's awesome, I can do that. So yeah.
Cool. Well, thank you very much for. I don't see any questions in the chat right now, but is there any call to action you want to make before we close out?
Thanks so much for having me. I hope to visit y'all IRL sometime.
Yeah, thank you very much for speaking. I really enjoyed the talk, and live coding too is always.
Yeah, thanks to the person who was like praying to the live coding gods. I was a little bit nervous, but it worked out. So
yeah. Well, thanks again. All right, bye. So we were wrapping up with Chippy. I would like to, before we close, Ali is going to do a raffle. But I also want to remind you to like and subscribe. Like, we have a lot of other events on our Chippy channel that will be posted as time passes. So I hope you would be able to join us for that. And but without further ado, I will bring Ali back on, and he will do the raffle.
Hey Joe, thanks for all the hard work you put in today. This is a fantastic event, and thanks to all the speakers. I definitely learned a lot, and I can't wait to I guess like not really go home, stay at home, and try out what I learned. But yeah, we are giving away a ticket to next week's Python web conference. I'm going to be also live coding. It's not going to be as smooth as what we saw Jess do, but here goes nothing. There we go. Okay, so I have a list of folks that entered. So there's a total of 6 names. So let's just go input string equals 3. And then we got people equals person and input string dot split line. In for person and yeah, there we go. Live coding is not the most fun. Okay, people, there we go. All right, so we're gonna do import random, and then we'll do random.choice, and then we'll do people. All right, so congratulations, Courtney. We'll be contacting you with information about how you can redeem your ticket.
Great.
Right, that's it for me. Thanks so much.
Thank you very, very much for your help tonight, Ali, and good seeing you as always. That is Chippy. I really appreciate all of our great talks. Thank you to our speakers. Also, thank you for tuning in, and hope to see you at our next Chippy meeting. Again, we have a few coming up, so check our meetup.com. Thanks again, and talk to you soon.